Everyone, welcome back to TechCloud channel. In today's video we are going to discuss about the fragmentation and reassembly of IP packet in the network. So let's get started. In the first, let's know that what is the difference between fragmentation and reassembly. So in a very simple word, the fragmentation means dividing a big packet into a smaller packet, which can fit in the network path. Simple. And reassembly is just opposite to this, that rearranging or arranging back the divided packet into one or original packet. Okay, so what happened, the main importance in this difference is MTU. I hope you know about this, or if you don't know, we have already made a video on it and uploaded, so we will share a link of it so you can just go and watch there too. So MTU is something maximum transmission unit, which is by default 1500. Okay, so each devices, let's assume we have a PC here, and then a switch, then a router. So each side of the router became a separate network. So now a PC connected to the switch, then switch connected to the router. Similar way, router connected to a switch and switch connected to the router. So by default, each devices will have 1500 of the MTU, and including MTU, there is one more thing, which is PMTUD. PMTUD, path maximum transmission unit discovery. So what happened? Let's assume again that this PC is having a MTU of 1500, then this switch is having of 1500 of both interface, then on the router, this is switch, this is router, switch again. So on the router, now we have on one network throughput or interface we have 1500, on the other side we have something like 1480. Okay, and then again they have the default one 1500, the MTU. The moment user send a packet, and that packet by default will have the 1500 of MTU. So switch will look into it and then see, okay, it has 1500 MPU, then it can pass through the network. From switch, it will go to router, this interface, first interface. So here it will again pass. So router has to now forward the packet to the destination network. On the destination network interface, router will see that the MTU of this interface is less than the MTU of the packet received from the source. Router will reply back to the source and say that we need fragmentation here. We need a fragmentation here. What will happen now? So this PC will now again, you might have heard one more thing also, TCP retransmit. That is responsible for whenever this kind of fragmentation happening, or in case of a data loss in the directory to the path. So now what the source will do, source will do the very minimum possible fragmentation. So suppose to pass through 1480, how many packet it has to create, how many packet it has to divide into. So it will become like 1400 for one packet and 100 for one packet. This each packet will include all the header and sequence also. Under the header there will be sequence. That sequence will help them to reassemble it. On the first path now, so they have fragmented the packet, and that packet will reach to the router again. Here on the router will see now the packet size is less than the MTU size of the router. So now it will pass through the second network B, and then it will reach to the destination PC. On the destination PC, now destination PC will resemble it, and because of the sequence and all the headers, it will resemble it back. So it will be something like this, 1400 and then the 100. So it became again the 1500 of the packet. Okay, so how this PC is resembling is the question here, that we always get confused about. If fragmentation is happening, source is doing fragmentation, that's okay, but how it is being resembled at the destination end. You might have heard about OSI also and TCP IP. Okay, so they follow a method called from source they will do encapsulation, and from destination there will be decapsulation. So for encapsulation they add the header and then send to the destination. Similar way, for the decapsulation they will remove, the destination will remove the packet, that end it will remove the header from the packet and then open it for the destination. So that's how, in terms of doing this encapsulation, they perform the fragmentation and defragmentation and reassembly also here. So this is a high level and simple way of this fragmentation and assembly here. Now let me show you something. On the screen you will see, so here we have Wireshark packet capture. Just bottom to this you can see it says it needed a fragmentation here. This is the length, these all are the length. So in this length it found that there need a fragmentation because the destination is unreachable for that the big MTU region or the small MTU region, like that. Similar to this we can find it here in the detail, that why the fragmentation needed, because source must be sending a packet of 1500 by default MTU, and then the next of MTU is 1350. So this is the reason router send a reply to the source to do fragmentation, and even it shows in the Wireshark, if you find it, that it will say destination unreachable in the packet, in the application packet under that, and you will see also it's saying for the fragmentation need. So this is all about fragmentation and assembly today. Thank you for watching, and do like, share, comment and subscribe, and let us know in case of any query. Thank you.